Brought to you by Reflection. Without it, you couldn't see yourself.
The bending of waves due to a change in speed is called refraction. Waves usually travel in a straight line. But what happens when waves pass at an angle from one medium to another? As you can see, the wave bends. When the light wave moves from the air to the water, the wave slows down, causing it to bend. The bending of waves due to a change in speed is called refraction. As waves pass at an angle from one medium to another, such as light entering and exiting this diamond, they may speed up or slow down. The speeding up or slowing down of light is what causes refraction.
As we already mentioned, light can be absorbed or reflected. Look at the shape of this pencil as it passes down into the glass of water. The answer is refraction. The property of light that makes objects look differently in water is called refraction. Refraction occurs when light passes from one medium to another. As light passes from air into water, it slows down, causing it to bend when it strikes the surface at an angle. The bending of light causes the pencil to appear as if it's bent. Refraction also causes objects under water to look bigger than they actually are.
See that can? Right there on the bottom. I'm going to reach for it with this grabber arm of science. But watch what happens. As I aim for the can and squeeze, I miss. No, I'm really trying to get it. Here's what's going on. The light bouncing off the can is changing directions as it goes through the surface of the water. And so the can looks like it's in a slightly different position than it really is. And I miss. But if I compensate for the refraction of light, I can probably get it. I'm going to aim a little lower. Got it. You want some?
Here's a light trick that doesn't need mirrors. Put a penny in a pie pan. Now move back so you don't see the penny. Don't move, because I'm going to pour the water in. It's okay if you make a mess. Pretty cool, eh? See, light's always bouncing off the penny. But when you pour the water in, it makes the light bend. And the bending of the light makes the penny reappear. But the penny didn't move through all of this. But don't take my word for it. Try it!
See, we don't see things. We see light bouncing off a thing. So take a look at this. It's our light source water box of science. And in here is water with some tiny particles in it. And over here is a very strong light. So light comes into the water box, it hits little particles floating in the water and bounces off of them straight to you. When light hits a mirror, it comes straight onto the mirror and bounces straight off. Watch. Straight on, straight off. That's what scientists like you and me call reflection. Reflection is a word you've probably used before, like when you see your reflection in a mirror. Oh, God. Whew. Sorry.
Coming soon from Photon Pictures. In the Old West, things were different. In the Old West, straight-shooting ruffians ruled.
I'm as straight shooting as light is. No, you ain't.
are not, and 2 are not.
Photon Pictures presents Lights Out at the IC Corral, a place where straight shooters rule until she came to town.
Try your beam.
Don't miss Lights Out at the IC Corral. Coming soon at the speed of light through a projector in a quasi-multiplex mini-mall conglomeration near you.
When we see objects in a mirror, we're looking at light that's bouncing off the object and bouncing off the mirror and then coming into our eyes. Here's the thing. Parts of the object that are on the object's right stay on the right. Parts of the object that are on the object's left stay on the left. It's a mirror image, for crying out loud. See, we're facing the reflection, not the object. So that's why we have ecnolibmus. Ecnolibmus.
Hi, I'm Penn, and this is my partner, Teller. We're Penn and Teller. Did you ever, I don't know, look at yourself in a spoon? Well, if you look at yourself this way, you're right side up. But if you look at yourself this way, you flip upside down. Why is that? Well, let's look at the spoon sideways. See, the upside down way, the light waves come in, bounce, and cross themselves, making you look upside down. See? Whoa, whoa, whoa.
When light bounces off of a flat mirror, it bounces off at the same angle that it hits.
Light rays approaching a surface are called incident rays, and the light rays bouncing off a surface are called reflected rays. The angle at which light strikes an object is called the angle of incidence, and the angle at which light bounces off an object is called the angle of reflection. The law of reflection states that the angle of incidence and the angle of reflection are equal to each other.
Silence, please! The wonderful world of color. There's no such thing as color. We live in a colorless world. Ah, color is an effect produced in our eyes and brains by light. White light consists of different lengths of light waves. Each wavelength produces a different color sensation. A banana looks yellow because its surface absorbs all wavelengths except yellow, which is reflected back to our eyes. In the same way, a cherry looks red because its skin absorbs all colors except red. And vanilla ice cream gives the illusion of being white because it reflects all wavelengths of light. So, color doesn't really exist, but it does have a very real effect on us.
When white light passes through raindrops or through a glass prism as seen here, it gets separated into different component colors.
Science, please!
He was the real smart guy, and he had caught my eye. I said, hey, sweet thing, you can ask me anything. So he said,
My, oh my.
He said,
Why is the sky blue?
the white light stream from the sun, you know, contains all the colors of the rainbow. When the sunbeam penetrates the atmosphere, the blue light is deflected by the particles in the air, while the yellow, red, and green lights travel in straight line towards the earth, and that's why the sky is blue.
That's why the sky is blue.